fine. So today we are gonna solve the problem from LeetCode 75, the first problem from bit manipulation. So let's solve this. I have already solved the LeetCode's problem of the day for 2nd February. Sorry. So you should also see that video to see the solution for this problem, for that problem. So the first problem from bit manipulation is count bits. So given an integer n, return array answer of length n plus 1 such that for each I 0 to n, right? Okay, answer is the number of ones in the binary. Okay, good. So what is the question? What the question is, we have given n, right? So we have given n. What we need to do, we need to create an answer in which we have to return the number of ones. Okay, so I can say fx is the function which return the number of ones, fx of 0, fx of 1 and fx of 2. So this we need to return, and fx of 0 is nothing but 0, because in binary representation of 0 there is no 1, right? So this is 0. In fx of 1 there is 1 present, right? So so the binary representation of 1 is 1. So fx of 1 is 1 and binary representation of 2 is 1 0. So there is total 1 present, right? Number of ones are 1. In 5 this is the case, right? This is the case. So this is fx of 2, fx of 3 is, so 3 is 1 0 1 1, so this is 2. 4 is nothing but 1 0 0, so this is 1. 5 is nothing but 1 0 1, right? So this is 2. So this is the answer. So let's solve this. So this is a very pretty simple solution. We just need to count the number of ones present in the number, right? So let's make the answer is 0 for I in range 0 to n plus 1, right? So let's def fx of self x. So how to count number of ones, right? So how to count number of ones? So what we can do, so count equals to 0 for I in range 32, right? We can check that in this constraint, right? Total number of bits present is 32, right? So if 1 I and x, so this is a shift operator. So let's shift operator, right? So what is shift operator? So let me explain it here only. So shift operator is nothing but, if this is the bit, right, and we shift this, we shift to 2, this is a right shift, right? So and I is, let's say, 2, so this will be shifted towards the right by 2 elements and appended with 0. So this will be like 1 0 0. So this will be shifted to the right, these will be vanished and will be appended with 0. And if we are using left shift, right, so this is this shift 2, right? And if we are using this shift, right? Hello, आ जाओ आंटी, आ जाओ, right? So this will be getting shifted towards the left, so this will be like 0 0 0 0 1. Okay, and if it is like this, okay, and we are shifting towards the right, so this will become 10100. So now what we are doing here is here is, so let's say x is 00100, right, and we are shifting one is nothing but 00001. We are shifting one with I means, let's say I is 0, so this will be like this only, there is no shift, and what end operation is doing, this will become this, and this will become 0. So this means there is no bit here. So let's shift it, right. So if I become 1, so we got to know that if it is a set bit or not. If I is 2, so this will get another shift, and we got to know if it is set bit or not. So yeah, if it is a set bit, so the answer will become, so the end will become true, and we got to know that it is a set bit. Then again we are left shift here, and we got to know that it is not a set bit. So this is this operation is to count the number of set bits, right? And this operation is to check that at ith position of x if it is a set bit or not. So this is a standard operation, right? So if it is a set bit, so what we will do, we will count plus equals to 1, plus equal to 1. We will do this, we will count that bit. And this is the standard way to count the number of bits. There is also another way. So the count set bits in a number, I think there is also an inbuilt program for that. What, so as you guys can see, that's only we are doing. There is also, so this is converting into the binary formation and then counting the 1. So this is another way, right? So anyways, we are doing this, and we are returning count, okay. So answer dot append count I, and we will return answer. So the time complexity is 32 into n. So we are doing a 32 iterations here, right? And we are doing n iterations here, so this is 32 into n. Space complexity is nothing but n, right? So let's run this. Oh sorry, it's a self dot count, sorry, here sorry, self dot fx, okay. Answer, we are getting the answer. Let's submit this. So yeah guys, we are solving this in a not very optimal solution. Let's see the optimized solution here. Okay, so this is another way to count the number of bits. Okay, okay. So this is pre-calculating all the okay, good. This is another way. So what we are doing here is, so for, let's say, for getting the answer for, let's say, 2, we are calculating the answer for 0, 1 and 2, and for calculating the answer for 3, we are again calculating 0, 1, 2 and 3. So what the guys are doing, they are pre-calculating everything, right? So let's say def count here, let's do this, right? let's say. So in this solution we are just pre-calculating everything before making this solution instance, and then we are just returning the answers, right? And we don't need this self here because this is out of the class now. So so this is dp, nothing but this for I in range 10 to the power 5, so 10 to the power 5 1 2 3 4 5. What is this? So dp dot append fxi. So this is what we need to do. Okay, so now return return dp n plus 1. So yes, this we can solve this in this way only. This way also, sorry, syntax is invalid. What is the problem? I don't know what is the problem here. This is fx count, good, return count. fxi, okay. What is the problem in this syntax? Okay, let's copy this. This is the exact solution we are doing, right? We are counting the ones here, we are appending to the dp here in range for x in range. This is appending. Okay, sorry, my bad, guys. Yeah, so it is getting solved and I hope this will beat 100%. Yeah, so I hope you understand this dp's problem well. Thank you for your time, thank you for your patience, thank you for watching this video. If you want, you can share this video with your friends also. We are what we are doing is we are solving LeetCode problem of the day every day, and we are also solving LeetCode 75 every day, and so you can go through this playlist and check the videos there. I'm a beginner in this YouTube journey, so please forgive me for my and I apologize for anything like not actually apologizing, but I'm trying my best to give you the best content. So thank you for your time. Thank you.